Okay, so this is the examples for Algebra 1A, Credit 1, Lesson 2.2. All right, our first example for number 1, we have negative 200 equals 40x minus 80. We're focused on the right-hand side because that's where x is. First thing we do is deal with our subtraction. So the opposite of subtracting 80 is to add 80 to both sides. The 80s cancel out. And then over here, the signs are different, so we subtract 280. 200 minus 80, and we get 120. And since the larger number is negative, meaning there's more negatives than positives, we have negative 120. And we, of course, bring down the 40x. Our second and final step is x is being multiplied by 40. So we divide by 40 to both sides. And the 40s cancel out. 120 divided by 40 is 3. And negative divided by a positive is a negative. So our answer is negative 3. For our second example for number 2, notice that x is on the left-hand side, so that's where our focus is going to be. And notice we have a number, negative 2, next to parentheses with no addition or subtraction in between. So that means that indicates multiplication. So we're going to multiply or distribute that negative 2 to both terms inside the parentheses. Negative 2 times 7 is negative 14x. Negative 2 times negative 10 is positive 20. Remember, a negative times a negative is a positive. And we're going to bring down that negative 22. So now we're focused still on the left side. We deal again with our addition and subtraction first. The opposite of adding 20 is to subtract 20. So we're going to subtract 20 to both sides. The 20s cancel. We bring down that negative 14x. And since the signs are the same here, we're going to add these two numbers. 22 plus 20 is 42. And since both numbers are negative, the sign of our answer will also be negative. Finally, our last step, x is being multiplied by negative 14. So we divide by negative 14 to both sides. The negative 14s cancel out. Over here, 42 divided by 14 is 3. And a negative divided by a negative is a positive, so positive 3. Next, we have our example for problem number 3. And what we're dealing with here is variables on both sides of the equation. So if we have that, we don't want that. So we need to get rid of one of these x terms. It's a little bit easier if we get rid of the x with the smaller coefficient. So since 15 is smaller than 18, we're going to subtract 15x to both sides of the equation. Notice that we're subtracting because we're not trying to get rid of just the 15, but the entire term 15x. And so these are opposites. They cancel out. 18x minus 15x is 3x. We bring down the minus 7 and bring down the 38. X is now only on the left-hand side, so we're focused on the left. Again, addition and subtraction is first. So the opposite of subtracting 7 is to add 7 to both sides. The 7s cancel out, and we have 3x as we bring that down, equals 38 plus 7, which is 45. Our last step, x is being multiplied by 3. So we divide 3. Division would be the inverse operation of multiplication. The 3's cancel out, and 45 divided by 3 is 15. And that's our answer for our third example that correlates to problem number 3. All right, now, on the next page of the lesson, on page 40, we have some more justifying our steps. And we're going to do one example that will assist you with both problems 4 and 5. So this will be an example for problems 4. Let's try that again. 4 and 5. 4 is a little bit shorter than 5, so we're going to do the longer example that will correlate more closely to number 5, but will also help you with problem number 4. So let's take a look at this problem. We're going to be given the equation 6x minus 3 times 10 plus 2x equals 3x plus 12. And so that's our given. And then in step 1, we have this. We have 6x minus 30 minus 6x equals 3x plus 12. And so we have to justify, or we have to say what property was applied to go from step one, or from the given to step one. So what you want to look at is what's different. So all the stuff that was just brought down that stayed the same, that's not going to help us. What's going to help us here is what's different. And what appears to have happened is that we have a number next to parentheses, so we distributed the -3 to both terms inside the parentheses. And we'll confirm that -3 times 10 is -30. -3 times 2x is -6x. So our justification for the first step would be the distributive property. Now in your packet, you'll just be checking the box. You don't have to write it out, but here we're going to write it out. All right, now to go from step 1 to step 2, we have on step 2, it says 6x minus 6x minus 30 equals 3x plus 12. And again, we're going to look and see what's different. So what's different here, it appears that these two terms have switched places. The -6 went over here, so it can be close next to the other x term, and the -30 went here. So when we switch the terms, we got to be careful to keep the same sign, which we did. When we switch the terms, that is allowed, and that's called the commutative property. Commutative property. Not commutative, but commutative. Commutative property. All right, so that is our justification for step 2. Step 3, we have this. We have -30 equals 3x plus 12. And so now we're going to look at and see what's different. Well, what's different is these x terms went away. And why did they go away? Well, they are like terms because they're the same variable with the same exponent, a 1 that's just not written, but we assume it's 1 if it's not written. And so we have 6x minus 6x, which is 0x, or sometimes we just say it cancels out. So what we did there is we combined like terms. So combine like terms is the justification for step 3. Right. Next, as we go to step 4, we have -42 equals 3x, and that's step 4. So we're going to examine the equation to see what we did to go from step 3 to step 4. So the 12 is gone. How do we get rid of the 12? Well, there's nothing to combine it with. So the opposite of adding 12 is to subtract 12. And if we do that, it goes away. And just to confirm our answer, if we combine a -30 and a -12, the signs are the same. We add these together, we get 42. Both of these are negative, so our answer keeps the same sign. So -42, so that checks out. And so since we subtracted the same thing to both sides, the same term to both sides, that would be the subtraction property of equality. And so that's our justification for step number 4. And then finally in step 5, we have x equals -10.5. And so the only thing remaining to do here is x is being multiplied by 3, so it must be that we divided 3 to both sides. So if we divide 3 to both sides, we get -42 divided by 3. Whoops, I think we got the wrong answer there. Try that again. So it's -14. We're going to put that up. And so -42 divided by 3 is -14. So that does check out now that we corrected it. And so we divided the same thing to both sides. So that would be the division property of equality. All right, so that is how we do that one. That's the justification for each of our 5 steps there. On again, this is more closely related to number 5, but number 4, which is a shorter problem, it will help you with that. All right, so now let's go ahead and erase this, and let's talk about examples for 5 and 6. And let's go ahead and do that. All right. Or excuse me, 6 and 7, I should say. So this next one is an example for problem number 6. We're going to read, it's a word problem, as well as number 7. We're going to read the problem, and then we're going to just change the numbers to do a similar problem for the example. So here we go. Brian can type 50 words per minute. He needs to finish typing his 700-word essay and has already typed 375 words. Or has already, sorry, and already has 375 words typed. Write and solve an equation to determine the number of minutes that it will take Brian to finish writing his essay. All right, so in our example, we're going to have this. Brian is going to type 60 words per minute, and he already has 565 words typed. And what else do we have here? And it is a 1,000-word essay. All right. So that's not 60 miles per hour. Let's try that again. Words per minute. There we go. Words per minute. And we have that. Well, maybe we should write that out because we want to draw attention to the fact that we have that word per in there. And per tells us we're multiplying. And it also tells us very often that's where our variable is going to go. All right, so he's typing 60 words per minute. We're going to let X represent the number of minutes. So 60 words per minute times the number of minutes that he's typing. Plus, now he's not just starting out writing his essay, but he already has 565 words typed. So he's going to continue onward typing 60 words per minute. So 60 times X, again, per meaning we're going to multiply. And then plus the words he's already typed equals the 1,000-word essay that he's attempting to accomplish here. So now we have our equation set up, and now to solve it, just 2 steps. First step, we deal with our addition and subtraction. We have a positive 565, so we're going to subtract that to both sides. We have 60x equals 565's cancel out, equals 1,000 minus 565, which is 435. And then our final step, X is being multiplied by 60. So we divide 60 to both sides. And 435 divided by 60, let's just confirm that on the calculator. That would be 7 point, try that again. Make sure we have the right number here. 435 divided by 60, is 7.25. So remember, X represents the number of minutes he still has remaining if he can type, in order to finish his essay, if he can continue to type 60 words per minute. So it will take Brian 7.25 minutes, spell that incorrectly again, minutes to finish his essay. All right, so that is our example for number 6. All right, number 7, let's go ahead and erase that. And again, as we're going through these fairly quickly, hopefully not too quickly, but remember you can pause the video and rewind it, of course, to see again what we did and to better understand it. So number 7 involves a gym membership. Gym A charges a $25 membership fee and a $25 monthly fee. Well, Gym B charges a $55 membership fee and a $10 monthly fee. After how many months will the amount of money paid to both gyms be the same? And what will that amount be? All right, so let's take a look here for our example for number 7, the last problem in lesson 2.2. So Gym A, in our example, it's going to be a $70 fee, $70 sign-up fee or membership fee, and $70 per month. And again, there's that word per, so that's going to a clue as to where our variable is going to go. For Gym B, they charge a $100 sign-up fee, $100 to sign up. And that's and then on top of that, it's $60 per month. And what we're trying to do is find out when we pay the same amount to both gyms, regardless of which gym we chose. So notice what's going on here. Even though Gym A is less of a fee to get started, they charge more per month. And so eventually, since they charge more per month, even though it's a smaller initial fee to join the gym, eventually, because they're charging more per month, you'll be paying the same amount as Gym B. Let's put that up there. And after that, Gym A will become more expensive than Gym B. All right, let's take a look at how we set this up and how we solve this equation. So Gym A is a $70 flat fee, so no variable there. And then plus $70 per month. So that's where our variable is going to go, because every month is going to, we're going to be paying that amount. So 70 times X, with X representing the number of months. For Gym B, we set it up similarly. It's $100 to sign up, plus $60, there's the word per again, per month. And so that tells us that we're multiplying, and that's where our variable goes. All right, so just like we had on one of the equations back on problem number 3, variables on both sides, we have that again here. We have 70x and 60x. Since 60 is a smaller coefficient, we're going to get rid of that term by subtracting it to both sides. Subtracting 60x to both sides, we have bring down the 70. 70x minus 60x is 10x. We bring down the 100, and these 60s cancel out. Now the x is on the left-hand side, so that's where our focus is. Again, we deal with our addition and subtraction first. So that's the positive 70, the opposite of a positive or adding 70. And by the way, we know it's positive. The sign is always to the left, but if there's no sign there, we assume that it's positive. So that's why we subtracted 70 to both sides. The 70s cancel out. We bring down the 10x, and 100 minus 70 is 30. Our last step is x is being multiplied by 10. So we divide by 10 to both sides. And we find out that x, the 10s cancel, and 30 divided by 10 is 3. So in 3 months, both gyms will charge the same amount. Now, they also ask us, what will that amount be? So we're going to take the expression for either gym. We could do both to confirm our answer, but we only have to do one. So we're going to take the expression for Gym A, 70 plus 70 times 3, because 3 is the number of months until we will have paid the same amount to either gym. So we substitute that 3 in for x, and we follow the order of operations. We have multiplication and addition. Multiplications first. 70 times 3 is 210. Bring down the 70 and add these up. 70 plus 210 is $280. Now, again, we don't have to do both, but just real quick to show you that regardless of which expression we chose, Gym A or Gym B, we'll get the same answer, because again, in 3 months, we're paying the same amount to either gym. So we have 100 plus 60x, but we know that x is 3, because again, after 3 months, we're paying the same amount to both gyms. We multiply first. 60 times 3 is 180, and 100 plus 180 is 280, confirming that after 3 months, we will pay the same amount, and that amount is $280 to either gym. All right, that's it for lesson Algebra 1A, Credit 1, Lesson 2.2. And good luck with the problems, and do your best.